Now we go to 3.3.2. It says we are to calculate what the magnitude again, can you see, of the displacement of the projectile after 12.5 seconds. So that means I must take the yellow triangle, take the green, and also the orange because it's up to 12.5 seconds. All right, so we already have the area of the yellow. Let's work out the area of the green. All right, so I'm gonna write that as 3.3.2. So since I'm dealing with the area of the green section, I'm also gonna take a liberty myself to use a green color for that one so that we can identify. I'll say area equals to. Now, it's a triangle, so it's half base times height. All right, so it's gonna be a half. And then the base, let's look at the base, is gonna be from 5 to 10. So you take 10 minus the 5, so it gives you 5. So it's gonna be 5, close the parenthesis. Now look at the height or the depth from here to there is negative 49. So I'm gonna put it as negative 49. Remember, this is for the displacement. Displacement can be negative. So I already know the answer must be negative because the green is under the x-axis. Well, if you look at this and that one, it's the same answer as that one, numerically. So it's going to be negative 1, 2, 2,5 meters. But me, I'm going to give it direction. That will be when it's going down. Again, underscore the word magnitude. See, they're asking a magnitude. There we go. But we're not done. We also need to work out the area of the orange one so that the whole thing is done. So I'm going to work out the area of the orange one. I'm just going to do it right above there. So really, let's just call it A. That will be, that is in orange. Okay. So the area equals to, let's see what we're dealing with. The orange part is also a triangle. So it's going to be half. And then we need the base. The base is from 10 to 12.5. So what you do, you take 12.5 minus the 10. It must be 2.5. You can work it out in your head. It's 2.5. So it's going to be 2.5. All right. Into, we want the height. The height is from here up to that point. Look at that height. It corresponds with the V. That V, it's actually that V. And we had that V. There it is, it's 24.5. So then we can put it as 24.5. And our answer must be positive. Why? Because it's above. We're dealing with displacement. All right, not distance. If we're dealing with distance, every one of them will make them positive. Yellow, green, orange must be positive. All right, so we're timesing that by 2.5. We're going to times that by 24.5. And then bingo, there we go. So we've got 30, positive 30,625. It's meters, but that will be upwards. All right, so we could have figured it using our head. So now I'm giving the answer now. Here is the answer for our displacement. All right, up to this point. We add all these numbers together. So I'm gonna write, remember displacement is delta x. I'll say delta x, it must have an arrow to show it's a displacement, equals to, come on, I'm taking the yellow plus the green. So those two will cancel. You're going to end up with that 30. Just add them up, those numbers. Come on, you can do that. So I've got 30, 625. No need for me to round up to 2. It will be meters. So that will be the answer. But since they didn't request for the direction, but I'm going to give them direction myself. And I say it's up because that was positive. And I believe a job is well done. To God be the glory.